All right, guys, this is our Lab 1 Help series, specifically looking at Activity 1. So part of the instructions for this is that we have to do some calculations in terms of how you rated each video based on the criteria that you decided to use. So I have a mock data sheet called Lab Data 1. And basically what you can do is you can make a copy of this. I made a copy and called it Test Lab 1 Data. You can call it whatever you want. And then what I went ahead and did is I just made up some scores for 4 different raters. Okay. Now, you'll notice that in the original lab data sheet, there was this note for you guys over here. Make sure that when you have completed inserting your ratings that you delete that red box. For some reason, it confuses MATLAB, so it's just good if you delete it, okay? From here, once you've got your ratings imported, all you have to do is download as a Microsoft Excel XLSX file format, and then just know where that goes in your computer. Typically, it will go to downloads. So that's kind of the first piece of information that we need. So if I go into MATLAB online, I can go to the file pathway that I want for my lab. So I have a DANC 241 file in my drive, and then I also have a lab 1 folder within the 241 folder. So that's my pathway. And this pathway is where all of our directories are going to look for specific file names. So it's important that you have the pathway identified in the pathway bar. Okay, so my data I have saved in a specific folder on my computer. Like I said, your file probably went into downloads, so go to where this data set downloaded, and you can drag it into the current folder. Okay, so that's kind of one piece of information that we need. The other piece of information that we need is from the Moodle page, and it's in the Lab 1 Analysis Hints folder. Just to make sure that you remember how to get there, from the Moodle homepage, if you go to Resources, you can scroll down to Week 1, and it'll say Lab 1 Analysis Hints. What we want to do is download Lab 1 Analysis Hints MLX, so this is the live script format. You can see I've already downloaded mine, and it is located in my Downloads folder. So if I go to MATLAB, I want to also drag the lab hints file into a folder. Okay, and we're going to open that by double-clicking on the file title. And then you could see that we get our traditional live script view. So workspace, command window, and then we've got our actual script in the center. So there's a couple of things. I've been messing with this for several hours, and I think I found a nice way for you guys to pull information out of MATLAB. So the first thing I wanted to show you is entering the file name. So this is going to be calling upon the Excel file that has all of your rating data in it. Okay, so it does need to match this text exactly. So what I did to ensure that mine was correct is I just put XLSX. I just put the extension at the end by copying the actual text inside the folder. From here, you can run section, and you may or may not notice that there is an error. I ran into this problem several times, and I did find a way around it. So one of the ways is that we can call upon, well, first of all, you can see that variables were actually made, right? So if I double click on group dot, kind of us sticking all of this information into a map file or a map folder or matrix. So the problem with this is that the variable names, one, are not located up in these top columns. And the second thing is that we have all of these NaN values, which NaN stands for not a number. And so it gets really messy and very confusing on where things are. So I'm going to do two things that are, one, going to put these variable names up into these column headers, and then I'm going to get rid of all of these not a number signals, okay? So in order to get rid of the not a number stuff, I have to know the size of my matrix. And I can do this by looking at the file that had been downloaded, right, from Google Sheets. So you guys put in all of your ratings. And basically the way that Excel works is it is a matrix in itself. Instead of using numbers to identify rows and columns, it uses numbers to identify rows, and it uses letters to identify columns. So if you click on a certain cell, you can see its location within this larger matrix. So I want to know the size of a matrix that has the relevant data that I'm interested in. Okay, so we know that these are our variable names. And I just know from looking at my data that the first row, if we're not counting variable names, the first row should be video 1, the second row should be video 2, etc. So we don't really need this ID column when we input or when we take our relevant information into MATLAB. So what we could do to find out the size of our matrix, what you could do is highlight the relevant information. So this would be all of the rater data. So if you only have 3 people, it might only be to column D. If you have 5 people in your group, you might be to column F. Okay, but we highlight the range of data that we've collected, and then we could see the actual dimensions of that matrix in this little left-hand corner. So this area is defined as B1 to E6. So I'm going to take that information, and next to file name, I can specify in quotation marks B1 to E6. And so if I run this section again, I should get a beautiful table. And I'll actually click on this group dat. You can see the new matrix size is a 5 by 4. And if I double click on it to kind of expand it a little bit more, we can see that these row values we can just assume are video 1, 2, 3, 4, and 5. And then we have our raters 1, 2, 3, and 4. Okay, that's what we want. So from there, now that we have this nice little matrix, we can go down to lab activity 5A and 5E, this section. And this is where we are going to be calculating the means and standard deviations for each rater, as well as for each video. So this should be blank for you guys. And basically what it's asking is to identify a certain variable name within this table. So I can easily say I want the group mean, or the mean of our group data with a variable name specified as rater 1. So if I run this section, you can see that I get a mean and standard deviation, right, of 31.8 and 15.07. So in my lab document, right, I'm showing an example here where I have the mean of all of Judge 1's scores and the standard deviation of all of Judge 1's scores, okay? I could do the same thing for rater 2, rater 3, rater 4, however many people you have in your group, and you would be able to basically fill in this column, okay? Now, we also need to find, according to these instructions, the mean for each video. So this is just saying, what is the average rating for this dancer among however many judges you have in your group? And this one is a little bit more complicated. I don't know if there is an easier way, but this is the way that I was able to figure out. So I'm going to just create a new section and comment that this is mean and standard deviation for our videos, okay? So we have to do a couple things first. Whenever we do a mean function, generally it will say for a given variable, what is the mean of all of the row values, right? So row 1 plus row 2 plus row 3 plus 4 plus 5, and then we average that. But in this case, we want to actually know what is the mean going across. So what is the mean for our columns? And I wasn't able to make this work in certain ways. So we kind of have to do a roundabout way of getting this table the way that we actually want it to. So the first thing I want to do is just pull out the area of interest in my table, which if I expand this again, I only want to calculate the means of these values here. So what I can do is I can make a new variable called video, right? And you could do this for each video if you want to, but I think it might be easier just have a skeleton and then just change numbers as you go. So I'm going to call this variable video, and I want video to read the group DAT file, but I specifically want it in row 1, so I can specify row 1. And then you can see in the syntax prompt here, if we put a comma, that will take us to reading in the variables, okay, or the columns, which I technically want to be 1 to the end of the matrix. So I could put 1 to end, okay? So let's see what happens when we do this part, okay? You should notice that I'm going to close this really quick. You'll notice that I get this, okay? So it's just video 1, and it's showing all of the rater values. What I can do after this is transpose that data. So I'll just call this trans, right? And basically what you do is you change a row to a variable, and that's exactly what the function is called. So if you start typing row, you should see row to vars. And pretty much what we do is we say row to vars, and then we identify basically the matrix that we want to change. So in this case, I just say video, and then if I run this, you will see that it now flips, and so it's the variable. And this is more or less familiar to our eyes, right? So from here, I can now calculate the mean of these values, right? So it'd be this very similar to how we've done stuff already, where we identify the group of data that we're pulling from. So in this case, I created a new variable called trans, and I specifically want dot, right, the mean of the var1 column. So I could put dot, and then I can choose var1 or whatever corresponds to this area. I could do the same thing for the standard deviation. So I can also list my trans variable, and then again identify the standard deviation of var1. So now I can run this section, And you'll see that I get a mean and a standard deviation for the entire video, okay? So I'm going to switch this view back to what we're used to, right? And so pretty much if you use this portion, you get the mean and standard deviation for the video. So in this case, this is 21.5 and 3.4. So those would go here. 21.5 plus or minus 3.4, and then I can get rid of the square bracket, okay? And so that would be for video 1. If we wanted to do the same thing for video 2, 3, 4, or 5, all we have to do is change the row, right? So let's say I wanted video 3 or dancer 3. I just change this to a 3, and then I can run this section, and it should give me a mean and standard deviation. So for the purposes of you guys, you can go ahead and add semicolons to the ends of the first two lines of code, because we don't really need to see the tables. I just did that so you knew how I was building this part. But if you just want the mean and standard deviation displayed down here, they'll be the last two values because those are the last two lines of code that you ran, right? So in this case, I want the average of video 3, okay? I mean, if you want to look at the tables to make sure that you ran everything correctly, totally fine, right? Just remember that from this original table, you are taking this row. So when it goes into its own little vector, it's going to be labeled as 1. So don't let that confuse you, but you could see that the values going across this way are still in agreement with each other, okay? So we get 18.2.8. Great. We can go back to our table. We calculated that for video 3, and then we would put those values in this area, okay? I feel like that part was not as intuitive, and I don't think that part was accounted for when Aston was making the code, which is totally fine because I figured it out so, with my limited MATLAB experience. And then the last thing I wanted to cover was the correlation. So if you'll remember, this is the correlation equation that was created for the practice stuff that you guys did in class a little while back. And so what this does is it creates an output for variables R and P. R is your correlation coefficient. P is going to be indicating the probability that you made an error. It also is a way of identifying statistical significance. So typically when P is less than 0.05, which is the alpha level that we're using for this class for the whole semester, if P is less than 0.05, that means we have a significant relationship in terms of the correlation. So that's just kind of helping you to understand what the output is. And then the actual core, this part, right, is the correlation function. And all you have to do is identify two variables. So we're calling upon our chat field data variable name 1, which we're going to identify in this top box. And we're comparing it to data points of another variable that we're going to be identifying as variable name 2. So this is going to call back to our chat field data. However, this is also another error in the code that I found, because you actually want the correlation between rater scores in your group, not the chat field data, right? Because that is not representative of what your group collected. So instead of chat field dat, we're going to change this to group dat. so that it pulls from your group's data. Okay. And then all we have to do from here is insert our variable names. So let's say that I want the correlation between rater 1 and rater 2. And there we go. Okay, so I can click run section. It actually kind of automatically filled in here. But right, if I insert rater 1 and rater 2, it's just going to see from this original group dat, right? How do rater 1's values line up with rater 2? Basically what happens is we put these, we could put these on a scatter plot, and the more that the values line up, the more related or the more consistent each rater's values were, okay? So essentially that's what R tells us, is how strongly related are those two sets of data, right? And so with this information, for the given values that I made up, right, I can go back to my lab 1 data sheet. So just so I remember, 0.9, I'm going to round to the second decimal place, 0.97 and 0.0, I'll just say 0.01. So 0.97, 0.01. And I can go back here, and I gave you guys a correlation thing, right? The gray boxes you don't need to fill in. Those are typically redundant within a correlation matrix. So really all you're doing is you just did judge 1 and judge 2. So I can stick in my R value, which again, I forgot. I have a horrible short-term memory. 0.97 and 0.01, that's what it was. Okay. 0.97, and then this is going to be equal to 0.01, okay? You'll notice in the examples that were given during class time that P was listed as less than 0.0001. We only do this if P comes out to 0. And the reason why we have to put less than 0.001 is we're just assuming that the program that is calculating P does not have the ability to go past the amount of decimals that are actually shown. And there's never going to be a 0% chance of error. So we always have to say some error might have occurred, but the chances or the probability that our results are due to, you know, this specific relationship is very, very strong, and we're pretty confident in it, okay? So basically what you do through this is you have all of these different judge combinations, so judge 1 and judge 3, judge 1 and judge 4, right? And you just change these values respectively. So if I wanted judge 1 and judge 4, you can see these values changed over here. And then I can go back into lab 1, and I would input 0.95 and 0.01 in this box here, okay? And so then I think it's the first discussion question. It's asking you, how did your values correlate to each other? So this is the table that you would be referring to in that discussion question 1, which is hinted in the MATLAB hints area. So hopefully that is helpful for you guys. I think we're going to get through this, but this, I kid you not, took me like an hour to figure out. So if it doesn't work, I'm going to be so sad. But basically, just do exactly as I did, and then you just change the components that I told you to change, and we should be fine, okay? So once you get your tables, since they're already formatted in a doc of sorts, you should be able to just fill in and then paste. And remember, this is a view only for you guys, so you will have to make a copy, and then you can fill in the table from there. And I definitely recommend like working on this as a group, okay? So that you guys can help each other out and make sense of all of this. Okay, that's all I got for this one. Good luck.